Hello everybody and welcome again to Psychology 205. This is still Module 1. We are on Lecture 3 and today we are going to be talking about the 5 components of the scientific method. What is it that makes the scientific method scientific? Well, we're going to be talking about replication, objectivity, control, quantification, and self-correction. And remember that says that science rocks. If you can remember those, that's the little acronym to help you remember. So, what is replication? Replication means that we are repeating an experiment or a study to show that it can be done again. If I find results for my embarrassment study, for example, somebody over in Argentina might want to find out if the same thing is true over there, to make sure that I didn't make any mistakes or to make sure that it's actually true of people over in that other country. So it's always a good idea to make sure that you can replicate a study and you can get the same results over and over again. So part of the scientific method that makes it scientific is that we use replication and that we rely on that. Without replication, we can't be sure that our single study that showed something amazing is actually really useful at all. Maybe it was just a mistake. Maybe it was just dumb luck that we got our results that we did. So the second thing is objectivity. I've talked a little bit about objectivity before. It just means that we use methods that separate our biases from the observations that we're making. So because we're human beings, we come into a situation with hopes and expectations. I, as a research geek, really have lots of things that I hope are true for my hypotheses to be true. I really want X, Y, and Z to be true of my studies. So I want my study to come out the way that I want it to come out. I don't want it to fail. But that being said, I can't set up the situation of my experiment so that it will come out the way that I want. That's cheating. So that's why I have to allow the methods to make me objective. There are a couple of ways that I can do this. Again, I can't turn off my subjectivity. I can't make myself not care. So my objectivity is not through me, it is through the method that I'm using. Hopefully that makes sense. So one way that we can be objective in our methods is to use what's called a blind study. You guys might have heard of this before. It has nothing to do with vision, per se. It just has to do with the participants in the study not being aware of which condition they're getting. So if they are getting a treatment, for example, either a drug or a placebo for depression, let's say, if they know what condition they're in, if you know you're getting the placebo, it's pretty much a useless study. So it's really important to be able to have a blind study so the participants are unaware of which condition they're in. Otherwise, that might influence them and their biases will ruin the objectivity. But an even better way to do a study than a simple blind study is to do what's called a double-blind study. And a double-blind study is not what these glasses are doing to me, but in fact, when the researchers and the participants both are blind to the conditions. Now, that doesn't mean that nobody knows what's going on. Someone is keeping track of which condition, who's taking the drug and who's taking the placebo. But we aren't aware of the condition when we are interacting with the participants. So I, as the researcher, don't know if you, Joe Schmo, are getting the drug or the placebo when I interact with you. That way, I'm not treating you differently than if I knew that you were getting the drug, for example. So that removes my biases, because even if I have biases and I hope that you're going to do better on my drug, I can't treat you differently because I don't know which one you're getting. I will treat everybody, the same, based on not knowing which condition they're in. So those are two really important things to keep objectivity. Think about that for a second and think if you have read about any blind studies or studies that have utilized that method. And hopefully you can think about studies where if the researcher knows which condition people are in, for whatever reason, if it's a diet or a hair product for men, whatever it might be, if the researcher knows what condition, they might induce the placebo effect. If you guys have heard of that word, that false treatment effect that might actually make something happen just because the people believe in it. And if I treat them differently and if they have different expectations, together those things might work in spite of my treatment. And so maybe it's not really my treatment that's working. Instead, it's the expectations that both participants and researchers have that are creating the difference, the effect. Excuse me, I've got a cold still. Okay, so that's objectivity. Control. Control is basically removing all extraneous factors that we don't want to be a part of our study. Holding everything constant is one way that we talk about control. If we have control over our variables, that means that we are able to keep everything the same, all the characteristics and conditions of the study, except those that we want to manipulate. Now, by manipulate, I don't mean take advantage of or lie to. I just mean that we are going to change them in some way. So usually in an experiment, we have something that we want to change and see if it causes an effect on something else. So again, for example, if I have a drug and I want to see if it affects depression by decreasing it, then I might have people assigned to drug and placebo conditions. And in order to control that, one of the things is that the placebo condition is actually a control condition. It's a comparison group. And so it's a slightly different use of the word control than the extraneous variables, but it's an easier one to understand, I think. So the control group is simply the one that we compare to the treatment group to make sure that the changes that we get in the treatment group are real. If the changes that we get happen in the treatment group and we can't compare them to a control group, then we can't know if it's the placebo effect, again, that false treatment effect, the belief in that I'm taking this pill and it's going to make me better. Our treatment has to be better than that placebo effect. So it's always good, no matter what we're trying to do, whether it's fear or diet or hair products, we should have a control condition. In the control condition, the people are treated exactly the same as they are in the treatment condition, except they are given either a false treatment or no treatment. And that's a very important aspect of control. But the other part of control is holding everything else constant. So while we want to manipulate a variable, again, having people take either the drug or the placebo, that's what we want to change. We don't want other things being changed as well. We don't want male experimenters giving the treatment and female experimenters giving the drug. We don't want airplanes flying overhead sometimes and other times not. We don't want sometimes for the rooms to be ugly and other times for them to be pretty. We like for everything to be as similar and identical as possible. That's the kind of control that we're talking about in an experiment. When we hold everything constant, keep everything the same, and we only change the things we're interested in, then we can feel very confident that what we've changed has in fact resulted in the change that we are looking for. So the variable that we have manipulated, which I'll talk about more later, is the one that has caused the effect that I'm looking for. Okay, so think about control again for a second. There are two types of control. What's the first type? Think about it for a second. The first type, or either one, the control condition, and think about what that is for. And then secondly, what do I mean by control more generally? And that is holding things constant and keeping them the same, except for what I want to systematically and change in a way that I am in charge of, or whoever the researcher is, that you are in charge of when you do your own experiment. Okay, so that's control. Quantification, this is more complicated and we will spend a whole other session on this, but basically it's our ability to take some kind of invisible construct, usually invisible, something like reaction time or memory, and translate it into some way that we can turn it into numbers or quantify it. By quantifying, I mean we are making it numerical. Now, not all research does this, but for most science, we like to have a way to measure something in a way that we can ultimately count or analyze it somehow numerically. So basically, quantification just means that we're taking something like memory and we are defining it in a way like the number of words that you remember if they've been flashed for a 10-second period, or whatever the definition is. How many words did you remember? Or if I read you a paragraph, how many vocabulary words were you able to recall in a very brief period when I asked you? So again, taking something like memory and changing it to a specific thing that can be numbered, like number of words, number of numbers, etc. So that's quantification, and we will spend more time again talking about how we make those translations later. It's one of the most exciting and cool parts of psychology as a science, much easier than chemistry and physics, which are fancier maybe and have prettier colors, but still we have the invisible constructs to deal with. We have the things that are difficult to measure, like aggression and love and memory and things like that. So when we're trying to quantify those and make them into numbers, it's a real challenge. But you guys are going to become experts at it because I'm going to help you, and you guys are awesome. Finally, self-correction, a key part of the scientific method, because what it basically means is that science is a public endeavor. We don't hide things in science. We publish things, we get them out there, and that's not just so that we feel all fancy about ourselves and that we get, we don't really get a lot of money for publishing things or even much fame. What we do get is feedback from other scientists. And so if someone wants to replicate my study because they read it and they said, I don't think I agree with what your results were, I'm like, well, okay, that's the whole point. I published it so you could try to correct it and see if I'm right. So I put my stuff out there. Dr. So-and-so puts his stuff out there. Dr. So-and-so puts her stuff out there. And we all compare our stuff. We replicate each other's studies, or we examine them critically and see if we can find flaws in those studies. And then through that process of peers being motivated through science simply to find the truth, we end up correcting the science over the years. So science is self-correcting in that way. So remember, science, or the scientific method, rocks replication or repeatability, objectivity, or removing our biases through methodology, control, my thing is not working here, control, which means, again, control group, or holding all the variables constant except for the thing that we want to change, quantification, translating constructs into numbers, and finally, self-correction, which means that science is made public so we can critique each other's work and get it out there and make it better. So that is the scientific method, the 5 components, and I will see you next time. Take care.